without wasting time, we'll start that next panel discussion. We are more or less on time, but little delayed. So request people to join. It will be led by, it will be chaired by Mr. Sishendu Mukherjee. I request Mr. Mukherjee to join. Mr. Praveen Chaturvedi, Mridul also, please be there. Mridul, please be there. And Mr. Praveen Chaturvedi, I've seen him. Praveen is here. I think Praveen from Tenova. Yeah, good. And Mr. Varun Jajodia. Yeah. Okay. Mr. Varun Jajodia, Mr. Sushim Banerjee. Mr. Sushim Banerjee, I've seen him, he's here. Yeah, please come, sir. Please come. Here to the other. Mr. S.K. Nandi, the founder and MD of Macnon Consultancy. Mr. Somesh Bishya, Tata Steel, is here. Mr. Joy Mojumdar and Mr. Shankar Chaudhary. Yeah, Mr. Sharma is here. Mr. Sharma. I'll see. Okay, without losing time, I request Mr. Sushendu Mukherjee, who is a graduate from IIEST Sipur in electrical engineering and also completed postgraduate diploma in quality management from Mahindra Institute of Quality. He has over 27 years of experience in mining, ferroalloys, production and sales, total quality management, and also worked in business analysis group. He represents Tata Steel he represents different forum and ferroalloys producer. He is currently a ED Sham Metallics. Earlier to that, he was the chief operation in ferroalloys mineral division of Tata Steel. With a small brief, I request Mr. Sushendu Mukherjee, please to arrange this here.
So good morning, everyone. So I think we have covered a lot of points in the morning, but I have also noted down a couple of points which was discussed, but not deliberated. Maybe we have about an hour, about 1 hour 15 minutes, we can deliberate a little more. So if I have to look back Indian industry, I would look at it from 3 perspectives that I have written. One is obviously mining, second one is manufacturing. When you say manufacturing, steel ferroalloys are interconnected, so I am not differentiating between steel and ferroalloys. Supply chain is very, very important for the industry. I think when I say supply chain, it is not merely even steel and ferroalloys. It actually covers the entire country, when you look at supply chain. It is more so because of the situation that we are having today, and we deliberated a little more than that. The point which is also critical, and I have probably mentioned it in the last skill take also, the skill part of it. Skill development, availability of skill. And the last but not the least is on technology and research. I think these are top 5 things in my mind, and I will also request my fellow panelists to deliberate something that if I have missed. But if I have to give a summary, and everybody knows that India is about 150, 160 million tons of steel, close to 300 million tons of iron ore. Ferroalloys, I think, when I joined 1998, I think it is more about a little bit on a chrome alloys industry. Manganese is gradually developing those days, but now manganese has overtaken chrome big times. I think manganese today more than 4 million tons. Chrome is still around 1.3, 1.4 million tons. Primarily because chrome is more dependent on India's story. Means India's story not in Indian production, but Indian mineral availability or the chrome ore availability. While manganese is global, so we can import anywhere from the world. If I look at coal, I would say, I was looking at some figures. I think Coal India will produce more than 1 billion ton this year. And India's import of coal has come down by 80%. I think it's very, very difficult to believe. But that is what Coal India has done. And I think the government of India is also preparing a roadmap, or it is almost in the final stage, wherein we are looking at coking coal going up to 130 million ton in next 5 to 7 years. I don't know how many of us are aware about the figures. So India spends about, if I have to talk about INR, close to 1.3 trillion INR in importing of coking coal. So that's the number. Government is continuously looking at it. While it both, so I think it was easier for India to increase production through Coal India for thermal coal, and gradually we are moving towards producing more coking coal. And if that happens, I think the import bill, the government of India is the major target of bringing down imports, still will hover around, I think, oil and natural gas. I think that's something that we don't have, but what we have, can we exploit better? I think that's what government is looking at it. And before we open the discussion, I think the last point for all of us is, okay, so the India's GDP. I think India is growing somewhere between 6 to 8%. Different research firms have different numbers based on the baseline data. But if you look at the data, I think it's about 7 to 8%. I would say that's about 7%. But steel grows about 1.2 to 1.3 times of GDP. So therefore, steel should grow around 8 to 9%. And in a rough calculation, that means that if India is about 150 million tons, so India would need close to 13 to 15 million of steel, additional steel every year. And that's a big number. So therefore, if we are today at about 165 million tons, I would say we need about 220 million tons by 2030. And it is most likely, maybe it will be good that if I am wrong, that India needs steel and steel will come through import route. Because the projects, whether MNS or JSW or Tata Steel or even a lot of secondary producers have decided it will take shape maybe in 5 to 7 years. So I would say from a balance of supply point of view, steel will continue to be a good time going forward, because there's not a lot of steel will be produced in India, but the demand will continue to grow in India. That's a good sign. And if I link it to ferroalloys, particularly manganese alloys, I think manganese alloys, India is the largest exporter today. India will continue to be the largest exporter, but hopefully the volume of exports, which is 1.6, 1.7 million ton, may come down a little bit, based on obviously India's own growth story. The other factor which is bothering the industry little bit, or the ferroalloy industry, is CBAM, which is relevant, quite relevant today, because the energy intensity or the carbon intensity that we are having today, it will also save the industry that do you need to adopt relevant technologies going forward. So Praveen is there. I will start with Praveen, because since my closing remarks on the technology. So what do you think that India is very slow in adapting technology? Because obviously it lies with the capex, so everybody knows that capex will be higher, but with the CBAM or the declarations have come in that somebody has to pay additional cost if you breach the threshold. So do you think that India has a great potential to invest in the technologies of the future and continue to be a leader in the ferroalloys?
Thank you, Mr. Mukherjee. I think you have touched the right thing about the decarbonization and the CBAM, what you have mentioned. But before that, there are a few things which we may focus on. As you know, the steel market is booming. Means we have the target 300. Now we have 400 million ton of steel by 35, as Mr. Raman has told in the previous session. Accordingly, the ferroalloys will also come up. So more important is that demand will definitely be there. Demand is not going to reduce, and the winner will be there who is making the ferroalloys in a smarter way. So one, we have already discussed about the energy intensity, that is more important. Of course, that is the thing, because in India, most of the energy that is coming from the thermal energy, but now with solar and all, we are coming with the renewable energy also, that will also reduce the carbon footprint to some extent. More importantly is that we should have the process efficiency, in which how we can reduce the electrical energy, dependency on the electrical energy. Dependency, of course, we cannot reduce it, but how effectively we can use it. That is by various digitalization, like the energy optimizer, some of the things which we can do, because you know in ferroalloys what is going inside is the mass energy balance and of course the material. So energy, if we are able to efficiently use and increase the yield, because in the previous session we were also discussing about the poor quality of the raw material. So whatever raw material is there, we have to maximize our profit, because margin is going to be much more important. What Mr. Mridul will also agree, because he is a businessman. So he has to make the things, of course, in an economical way, in a sustainable way, and also meeting the challenges about the decarbonization, what we are discussing, whether it is scope 1, 2 or 3. Including the logistic. So those things, if we do, definitely we will be able to make it. So this is my say that yes, definitely the cost of the product will increase, but as I always say that yes, the customer is willing to pay for that green ferroalloys if we are able to make those product. Because once upon a time, you know, efficient thing and those things why I'm referring to. In Kolkata, you might be seeing once upon a time there were a lot of ambassador cars, but now those has been replaced by Suzuki and Toyotas and other things due to the efficiency, because of the fuel consumption, fuel economy. Likewise, if the technologies are available in which we can, if we cannot replace it, but at least we can reduce it, we can optimize the energy utilization through various technologies which are already prevailing elsewhere. Because making ferroalloys, whether it is in India, Ukraine, Russia, Iran, US, wherever it may be, the chemical process remains the same, metallurgical process remains the same, mass energy balance remains the same. The only thing is that how effectively, efficiently. In the previous slide, in the previous session, we were discussing about the South Africa. Why South Africa is not able to maintain? Because their energy cost is too high. So that is why they are not able to sustain in the market. So these are the things which we can address in this forum. And what are the technologies available? I'll just show you in the next slides, which has been adopted elsewhere across the globe and can be thought of in the present context also. Thank you.
Will you like to go through your slides now or later? Okay. So, Vinodji, I think you have, I would say you were the pioneer of thinking differently, okay, in India. And you have done a lot of improvements over many years in terms of carbon, in terms of energy. But is there a problem of the industry in adapting those, or people are not taking enough chances? I would not say they use the risk, because there is no risk involved, I would guess. But the transformation of doing something, or transformation of industry, or changing our thought process, that we need to adopt new technologies, new processes. Do you feel that we are doing enough, or we are not doing enough?
Thank you very much, Mr. Sindhu Mukherjee. Good morning to all the fellow panelists or fellow who are on the dais, and all my friends present. As Mr. Mukherjee told, that there are challenges in accepting whatever is coming to us. But it is mostly, I think, in our perception. The difference is there in the perception. Whatever we think as a cost, if we think differently, then it might be an opportunity, because cost pays back for itself if we go deeper into the chemistry of it. For example, Dr. Rajesh, he presented about availability of usable manganese ore, which is only about 20 to 30%, rest is going in the fines. But then this gives us an opportunity, how the fines can be extracted and beneficiated. Now, if we put an energy in the beneficiation and extraction, then it pays back in form of a compensation in the manufacturing process. This energy will be compensated in the manufacturing process because of the size reduction, and size reduction will facilitate better productivity. Only thing is, we have to take out this manganese through various processes. Same for the steel. In steel also, in fact, I remember one of my discussion with ex-Vice Chairman Tata Steel, Mr. Muthuraman, during his days when he was on the verge of leaving. I was in Chennai, and I asked him, sir, how do you see the future of iron ore and steel industry? He told, in future, steel industry will be more concentrated in southern part of India, not in the eastern part. I told, how, sir? He told, today there are challenges in beneficiating iron ore of eastern part, Jharkhand, Odisha, because of the high alumina content. Whereas we have large reserves of taconite ore, which is only about 30% Fe, but beneficiation is very, very easy. So those reserves are plenty in south. And once we start thinking that, yes, this ore also can be beneficiated, then the times and things will be different. So we must think differently in beneficiation. Lot of technologies are available like GOSTEC, WIMS technology, which can help in manganese ore beneficiation. Agglomeration as such, I think it is a challenge, and it may not be a challenge if you spend something in R&D. We do not have small R&D equipments. That is the problem. Once we start thinking, we always think in terms of how we can do it in the larger furnaces. But if it is done in a smaller way, I think there are ways and means to do it. Then, coming to phos and sulfur. Phos and sulfur certainly is a big challenge, very, very difficult to tackle the phos. Sulfur can be tackled in the furnaces or in the ladle treatments, but then phos is a very difficult thing. You have to see that right chemistry is maintained right from the beginning when you charge the material in the furnace. Lesser the phos, lesser will be the pickup in the ferroalloys or the metal. Now, I think these things have to be dived deeper into. The problems should be more and more discussed. And I think these should be discussed not only in the forum where we are the users or producers, we should also involve the institutes where there are a lot of thoughts. They have the smaller equipments, and if these two are integrated, I think the challenges will be much lesser. Thank you very much.
Thank you. So we'll come to Mr. Sankar Chaudhary. I think there is something that I thought that Praveen will address in his presentation sometime. So India, it's not about ferroalloys. I think if you look at steel and ferroalloys, both, we are still dependent on technologies from the outside. Okay, so what's happening? India is still, if you look at ferroalloys, it's still 9 to, I would say, 18, 24, maybe around 30 MVA type furnaces that we are looking at it. And we are predominantly a semi-open, semi-closed setup. But if I look back, the worldwide, I think the highest I know is 135 MVA, single furnace. So cost plays a very important role when we are looking at a bigger furnace, technologies, closed furnace. But it has also, as Sarmaji was mentioning, that it is also pays back. Because if you invest on something, you will also get your money back, because that's the potential of a technology. So why would not Indian, I would say, technology or the service providers looking at it differently and providing that economic solutions to the industry? If we look back that something can be done in India, so also it will be a part of Atmanirbhar Bharat, I would say that way, that if India starts converting the smaller furnaces into bigger furnaces with a closed technology, so I think it's something that I have been observing for the last 25, 27 years, but it has not taken any shape in India even today. So what is your view? So why are we lagging from our thought process to developing a technology or implementing a technology in India?
Yeah, thank you, Shishandu, fellow panelists and distinguished participants. Yes, this is a real challenge in Indian condition, that somehow this ferroalloys industry was not addressed with proper technical understanding, and it was basically a fragmented industry and not within the corporate sector. But it's a good news that these days the corporate sectors like Tata Steel, Vedanta, and they are coming in a big way in ferroalloys, and other small producers are also getting consolidated. So what happened, our ferroalloys industry goes back, in the first thing probably in this Joda plant was in 1952 or so, 58, yeah. So with that we started our ferroalloys journey, and in between, the few of the people who were working in this industry, they started introducing this ferroalloys, rather the submerged arc furnace technology to Indian market. So somehow here the scalability part of it did not come because, as Shishandu mentioned, that it requires capital. So it was really a capex intensive thing if we want to scalable it to a different level. Because at the same point of time, you have to think about the other peripheral facilities of this furnace. It is not only the furnace. The economy doesn't reflect only into the furnace, but it requires a good, to start with, a very good layout, and the other logistics problem, and the material handling system itself. So we have to also think on those lines when we are thinking of scalability of the furnace. And besides this, the handling of the finished product. Here is a great opportunity India can have, because till now hardly one or two companies who are doing this mechanized handling part of it. It is basically introduction of pick casting machine and grand shots in ferroalloys industry, because till date also we are making big cakes, we are quenching with water, and then subsequently it is manually carried to a shed, and then 200s of people are engaged in breaking them out. They are producing a lot of fines in this, and this way your total yield of the saleable product also goes down. So while we are thinking of making big furnace, we must introduce these cultures in this industry, that this is required. And there comes the EPC concept of industry, because individually one or two stray designers, they may design something, but ultimately an EPC integrator who can really take care of this, all this balance of the plant facilities to a modern facility, and subsequently the furnace is equipped with all these modern facilities. So, first of all, before, of course, the scalability we have to go, and definitely it should be there. But before that, we must modernize our mind, that we must intelligently engineer this industry, with a smart layout, with modular concept. These are the few things which must be introduced into ferroalloys industry. So if I take a 9 MVA furnace, today it is very crudely material is handled, it is charged into the furnace, and if you charge something into the furnace, something will come out. With this principle only our ferroalloys industry is working. So we have to really train this industry to handle smarter technologies and improved way. And also, a great thing is missing, which I will be presenting in my paper in the second half, that the waste gas utilization, the waste gas is just not utilized. We are only concerned about how much ppm is coming out of this thing. So 5 milligrams, 10 milligrams, we are satisfied. But a great treasure lies in this waste gas. And for that, what Sichendu told, that we have to change the characteristic of the furnace. Today we have open or semi-open type of, semi-closed type of furnace. But with, certain changes, these furnaces can be brought to near, closed furnace, where the carbon monoxide content in the waste gas should be 50%. That is the threshold limit where we can utilize these gases in a very, you will earn more money than by selling ferroalloys by utilizing this gas. Because by simple utilization, which is a very established process, that is water gas shifting formula, we can generate hydrogen out of this carbon monoxide, and then subsequently hydrogen can be separated and it is stored and it is sold as a sellable product. And the gas which is escaping from these things, that is from WGS reactor, and after that, of course, a PSA type of membrane system. The tail gas contains CO2. So that CO2 can be either captured and or the tail gas can also be used as recirculated into the furnace. So with this, and this decarbonization part, when you monetize, so it also gives you money. So you get a product which is hydrogen, which is as per Indian government target, that we should bring the green hydrogen price to $1.5 per kg. So if but today it is 400 to 500 rupees a kg. And secondly, the carbon dioxide is sold at 20,000 rupees a ton minimum. And of course, by carbon credit, you can earn minimum 2 to 4 crores of rupees. So with this, a tremendous EBITDA boost can be obtained. But of course, it requires investment, and that investment can be recovered within 2 to 3 years of time. And all the process involved in this are established process. This WGS reactor, then PSA type, these are the two basic things. And before that, the gas cleaning part of it. So I think first we should change our mindset in this industry to improve this industry to a stature where it can match with the steel industry. Because steel industry has gone up in a tremendous way with the level of technology and the people and the training, but ferroalloys industry not. Although it is one of the most important element in steel making. So I will request all the manufacturers as well as we EPC people and also the institutes to develop such pilot, and it can be, sea change in the total industry. With that, I will say to answer of Shirshendu that yes, big furnace can be done. It is not a not a rocket science. It is we have to only introduce ourselves into that mindset, and we can do it. And our institutes and our consultants in India should take leading role in this, and manufacturers should, ferroalloys producers should back up that initiative. With that note, I will conclude. Thank you.
Thanks. So Mridul, I think you started the day with India's glory, India's presence across the globe. Obviously, when the war started, we are importing crude from 27 countries, moved up to 40 countries today. All of us are feeling better that we don't have shortage in the oil and the petrol pumps. So if we have to look back, that India has emerged emerged stronger in last couple of years as far as I would say primarily manganese alloys. Obviously because of concerns at South Africa, Australia and other places. Majorly because of power tariff and the productivity level or the cost, I would say in some sense, the fixed cost part of it is relatively much cheaper. If you have to give a number, India's income in terms of dollars is still less than $3,000. Okay. So that's not so great for Indians, but that's some good news for the industry. So if you have to look back and say that next 5 to 10 years, where do you think that Indian ferroalloys industry would reach? Because as per our estimates, manganese alloys consumption will further grow by 2 million tons in next 5 to 7 years. So what is India's role in taking the market share of that 2 million tons?
Thank you, sir. A very interesting question indeed. In the next 5 to 10 years, as steel production scales up in India, when we go from 150, 165 million tons as of now, all the way up to 300 million tons and further after that, we would be seeing a lot of demand generation for manganese alloys in India itself, right? And quite a lot of times when I'm interacting with few of our customers, few of our sophisticated customers abroad, I get a question every time which I'm not able to answer. They ask me that, hey, India is, trying to increase its steel production rapidly. You want to double your steel production in the next coming 5 years, 6 years by 2030. Do you think that there will come a point in time where the government will stop the exports of manganese alloys or other ferroalloys coming out of India, and they would want to reserve that for the domestic steel industry? That is a question that I get from them, which I am not able to answer. But the sentiment behind the question is more important. The sentiment is that they, companies outside India who are consumers of manganese alloys are starting to have that question mark in their head that domestic consumption of manganese alloys in India is growing. So there might come a point where material may not be available for us, right? So circling back to Sir's question, that where do I see the industry in the next 5 years? Strong demand, no doubt, because we are seeing supply getting curtailed in other parts of the world, and we are seeing demand generation happening in India. So it's giving a very major bullish indicator to me. Obviously, it does not mean that prices will rise, profitability will rise. No, what it means is that no manganese alloy smelter in India would have trouble selling their material. As long as they can produce it for a cost-effective price, they have access to good energy prices, they have access to they have access to the right raw material. I don't think sales is going to be an issue for anyone, which means that there's going to be ample demand. There's always going to be home for the alloy that any smelter in India would produce. There is also a trend that we are seeing is there's a lot of specialty grade manganese alloys that have started to be produced in India over the past 2 years. Something that was not the case before when other origin smelters were more aggressive and more active. And going forward, this trend is just going to increase because companies or smelters who have been active in the standard specifications, they want to increase their footprint and go into something special which has higher barriers to entry. So that being said, uh, we are seeing a lot of we are foreseeing a lot of demand in the next 5 to 7 years, and as a result, there's going to be a lot of reliance on there's going to be increased reliance on imports for manganese ore, which some dignitaries, they pointed out very nicely that the local ores that we have, the domestic ores that we have, they are high in sulfur and phosphorus and also silicon for that matter, which consumes a lot of energy at the end. They are high in a lot of elements which are not favorable for us. But yes, if we are able to find beneficiation technologies, and if we are able to make them techno-commercially viable, then that would go a lot. That would go very hand in hand with the growing demand of manganese alloys and also the growing production capacities that are about to come online in the next 5 to 7 years. Thank you.
Okay, so a lot of positivity around. We move to Somesh, because if the steel industry does well, then the Mridul will also do well. So I think the point I started with, and that's a general perception that steel demand will grow in India, and everybody agrees. Somesh, so the point is that, post 2030, it is not the question aimed at Tata Steel, but generally on industry perspective, we are looking at a lot of disruptions in movement because of, mines will be auctioned, some mines may not be auctioned, some mines might be retained by the government. So there is a possibility that the disruptions on raw material movement might jeopardize India's future for steel industry. So what do you think could be an alternative to what's happening what could happen in India, and is steel industry prepared for it? That means that if I have to import iron ore or any other material from any part of the world, because world movement can happen, but generally I would say in India we are almost 97-98% self-sufficient in iron ore. We have not looked at that subject so closely so far. So what is your view that how is India going to address this concern going forward? Yeah. Little difficult one, but
thanks, Shishantu. It's quite a vast topic that you have given me to speak about. But being spent in raw material for some time and some time in strategy, I'll try to do my best to answer this question. So we know that decarbonization is a threat. I would say it's a requirement. It's a requirement for the globe, for the world, and we have to achieve that. So the use of scrap has to increase, but still the scrap will not be so much that it will be able to provide the metallics for 2 billion tons of steel at least that is being produced right now. So iron ore will be there in future, and iron ore quality is reducing as we have already know the quality of iron ore in China, quality of iron ore in India. And so a lot of things are happening. We see news in blending, strategies of blending being produced in Gannavaram. So people must have read about it. I'll not speak about it. So bringing ore from Brazil to India, blending it, and there's a market in India that will come up. Surely the growth projections of 500 million ton by say 2047. So it's a huge capacity. So iron ore requirement will be there. Iron ore cannot be replaced with scrap fully. So the blending strategy, which is already there in Malaysia, so Valley is doing it in Malaysia. They are blending it low-grade ores and supplying it to China. And that can be done in India also in a way. And India need to utilize, I think surely Rajesh has focused on ferroalloys, but he is know about it. He is an iron ore mining specialist. So that India needs to use low-grade ore, but the techno-commercial feasibility is the issue. China have been doing it over the years. They are the largest miners in the world, but of low-grade ore, and they beneficiate. Not only beneficiate, they do reduction roasting, grinding, reduction roasting, beneficiation, then maybe concentrated rate of around, say, 300 million tons out of that. That the figures that I had last. So, so that capability we don't have. There is still techno-commercially it's not feasible in India. None of us as producers of capacity to those type of, I would say, beneficiation and improvement in the quality of the iron ore. But those are requirement, and those are the need which is going forward till 2050 or 47, whatever the target is, those are required. There are challenges are there. So iron ore imports, I would say the financial challenges will all be there. So I will touch upon the challenges a bit in the sense, you already know the exchange rates what's happening. So we are trying to import certain things. It's very difficult to make it techno-commercially feasible in this part. Apart from that, challenges in the financial area in the sense of steel making is the interest rates. I would touch upon lightly on that, is that the interest rates in India are quite higher compared to the Western world or China in a way. So the need of profitability is much in India. So what happens, all these factors contribute to the project viability. Okay, so whatever viability in the sense iron ore project or steel project or ferroalloy project, in a way, it impacts in a big way. The few things that came into mind in this regard. Over to you, Shishandu.
Thanks so much. So I'll move to Mr. Banerjee, Susim Banerjee. I think spent many years in steel industry. So what do you think, sir, that how the steel industry in India is looking at technology as compared to what we are doing today? And then you can share your perspective about the industry.
Okay, thank you, Mr. Shishandu. Thank you, my fellow panelists, and very warm welcome to the guests, Steel Tech. At the outset, I must thank Mr. P.K. Sen, Mr. B.P. Sharkar for inviting me to share my thoughts on steel industry. Because as in the morning, we have been hearing about ferroalloys. Now the whole health and growth of ferroalloys industry must be dependent on how steel industry behaves in the future. So far, for the last 3 years, steel industry has been one of the fastest growing sector in the global market. As India also has been the fastest growing economy in the world in the current period. So somebody mentioned about the elasticity of steel demand, which is now more than exceeding 1. That means if GDP grows by 1%, steel industry grows by 1.2, by 1.3, and more than that. So that is a very cause for, great joy for all of us in the industry. Very recently, in 25-26, India has produced about 168 million tons of crude steel and consumed about 164 million tons of finished steel, which is about 12 million tons more than last year. And if you go by that, 12 to 13 to 15 million tons incremental consumption of steel. So next 5 years, that is by 2030-31, India will be consuming steel to the extent of about 225 to 230 million tons. This is the same, figure which we projected when the national steel policy was developed in 2017. We projected a demand for 235 million tons of steel. And I am sure at the rate at which we are progressing steel consumption in the country, we will be reaching that. So it is a cause for, great relief. At the same time, what are the challenges? Mr. Shishendu has mentioned about, some of the trade measures that the other countries are taking. One of them is CBAM, which is now going to restrict our exports. Incidentally, this is the first year after so many years when India has become net exporter. This year, we have exported about 8 million tons of steel and imported about 7.9 million tons. So it is a marginally, we are become a net exporter. And ferroalloys, I must say that this year we exported ferroalloys of 2.2 million tons and imported about 0.4 million tons. So that means the export opportunities of, not only ferroalloys but also steel is now going up. And that is a cause for joy. But at the same time, the recent West Asian crisis and the closure of this state of Hormuz is creating some problem. And I am sure this will be, creating some problem for the gas availability as well as the availability of LNG, LPG, as well as crude oil delivery to India. That may reflect in some sort of price inflation, which is going to happen. And only thing is that manufacturing sector price, if you see the growth, I think we are getting, steel industry is getting a reasonably good return, so that the capacity expansion that are on the anvil will not be, constrained. Now, my last point is, only yesterday, OECD has come out with a big report on future outlook of total global economy. On Indian part, surprisingly, they have said one of the biggest challenge of Indian industry is skill development, the lack of skilled manpower. And that is, we were, in fact, I was slightly taken aback that this is the first time they have identified the lack of skilled manpower. Particularly, they have mentioned the availability of manpower in the upper level of education. That means higher secondary and up. There is a significant gap of skilled manpower. And why they are saying so? Because they are saying that in the next 10 to 15 years, what are the 4 areas which will take away all the attention, all the energies, all the revenues of the government is, there are 4 areas. One is artificial intelligence foundation, that means cyber security, cloud, etc., semiconductor, etc. The second one is the digitization, e-commerce, etc. The third one is electrification, that is electric vehicles, renewable energy, etc. And the fourth one is hard technology. That means modular construction, the decarbonization technologies. And all these are so much relevant for Indian economy to grow. I think this is a report. I will request all of you to go through it, and particularly the Indian part. And I am sure some of the major action areas can be taken out of this report. Thank you.
Thank you, Mr. Banerjee. I think it's very insightful, the last 4 points. I would only top it up with one more thought that is coming to my mind. Is steel Indian industrial scale, it is formal, informal sectors. Because in the last Steel Tech seminar also I raised this point that how do you build skill? So it has to start from the school level. So if you look at our educations, it is purely that you have to read books, you have to go to the exam centers and write something and get marks. So therefore, unless there is a little change in our education system, it is very, very difficult to get skilled manpower in the country. That's my thought that, and I don't know, we have been discussing this subject multiple times with the skill centers and the ministry, but I think not much has been done so far.
Very, very relevant, Mr. Mukherjee, very, very relevant. In fact, if you see the current current state of employment of the particularly the youth. I am taking of 25 years to 35 years. The gig economy has become very, very relevant now. But you see the aspirational aspect. That is not giving their good aspiration. And for that, it is very much necessary that the school children, after they pass out, may reach 9 to 10 standard, then the new education policy has given them an opportunity that because of the parental pressure, etc., they have to earn something, so they can go out. They can earn for, say, maximum 3 years, and after that they can come back and join the education stream. This exit and entry policy has been introduced in the new education policy, for which there is a credit point system which has been introduced. And if the Indian youth can take care of that, the school living children, in fact, that has to be further told to them. In undergraduate stream, you will find many of the subjects still are being taught, for which there is no employment prospects. So what best the college authorities can do, that they continue to teach those undergraduate courses, but at the same time, some skill development training also must be introduced in each of the colleges. In fact, we proposed to our Ministry of Skill Development had proposed to the Ministry of Education that you develop or you establish a training center, skill development center in each of the education colleges, so that people can continue with their subjects, educational subjects, BA, BSc, BTech, etc. At the same time, they can teach, they can be taught in the skill development, but pertaining to their subjects. In fact, there is a great deal of emphasis on, artificial thinking, the creative thinking, leadership thinking. In fact, many of the industries, when we interacted with them, some of the MSME industries, they are short of leaders who can take those industries in the right path. So skill development in all these areas are very much needed. I do not know why the college authorities, university authorities are not so much aware of, so that in each of these centers, there has to be a skill development center equivalent to the subject that they are teaching. In fact, that is the golden way other countries they have done. South Africa has done, Zambia has done, Brazil has done, and they are getting good benefits out of that. So time has come in changing our total education system, and vocational education must be a part of the total education.
Great thought. Thank you. So I'll move to Mr. Nandi, SK Nandi. Mr. SK Nandi, his vast experience in steel plants and also in consulting with Mekon, Dostur. So I think we'll take that points forward further, that now India is also aspiring to be producing steel differently. That means either you talk about EAF, hydrogen, so which is also a fact that we need better skilled people if we have to drive those technologies going forward. That is one point. And second point is, the point I was mentioning to Mr. Sankar Chaudhary is that steel, even after, I would say, more than 100 years, I think India is still dependent a lot on importing technologies, not really, taken some decisions that Atmanirbhar, real definition of Atmanirbhar is still not being practiced. So what's your view, having so much of experience in steel industry?
Thank you, Mr. Chairman, and thanks to all your speakers. You see, I would like to stretch up a few points, mostly the problems and the prospects of ferroalloys in the industry. In my opinion, the first and foremost problem is the raw material availability. Over the years, whatever good ores we had, particularly manganese and chrome ores, they have depleted. And now the time has come to import As our earlier speaker has said, that last year we imported about 6 million tons of manganese ores. So, to improve the quality of our inputs, we must think of beneficiation, agglomeration. I think this has to be adopted by each and every plant. And the next is the high energy and operating cost. As we know that electricity constitutes about 20 to 25% of the total cost of ferroalloys. And our tariffs, our electric tariffs are very high, and that impacts our competitiveness in the international market. So third is our furnaces. Most of our furnaces are built on, I am meaning not the bigger ones, but the small furnaces on old technology. And that technology, due to that technology, our electricity consumption, our electrode consumption are very high. We have very high emissions. We don't have any control of SOx and NOx. And also, in most of the plants, this is the slag which is being produced. The reuse of that slag also is not being done. So I think that is a must. I think there should be some control over it, that the technology which have been adopted in those plants, this must be updated. Because in most of the plants, there is practically no or very little automation. And without automation, we cannot improve the energy efficiency. And then environment we have already touched. And then to increase the competitiveness. You see, if you have to increase our competitiveness in the international market, you see, you can say, opponents in the international market, mostly China, Kazakhstan, South Africa, Brazil. So these countries, they get lots of advantages in form of subsidized power, and also their materials and the government support. In India, practically there is no such support from the government, and so that should be applicable. And I think the whole industry as a whole should approach the government for such policies. You see, one of the ideas which came up some few months back in a meeting, that someone proposed that for ferroalloys industries, we should have a cluster sort of, that means industrial park, which will only have ferroalloys, which will have good road and rail connectivity. They will get subsidized power. Pollution control will be common for all the systems, for all the units. So that way, I think that this competitiveness of the industry as against our competitors will gradually increase. And second, what Mr. Chaudhary has said, that technology must improve. That old technology which we are having some 30, 40 years back, same thing are being used now, particularly for small capacity furnaces, 9 MVA, 12 MVA furnaces. So those must be updated. Without automation, I think we cannot improve the energy efficiency of the furnaces. And also at the same time, we must control the pollution. And then one good thing about the Indian industry is that we don't have to bother about the demand because with the steel production, as Mr. Mr. Banerjee has said, that 300 million by 2030, and so our demand for ferroalloys also will exponentially grow. So there is no problem of the demand now and also in future. And another thing that the value addition. The ferroalloys, I think already some of the plants here, they have adopted some production of low carbon ferrochrome. And this low carbon ferrochrome, particularly in the international market, they have got a very good demand, and it's a very, very profitable business up till now. But there also the inputs, you see, unless the input like chrome ore and silica chrome, which are being used as inputs, quality of those materials are improved, our competitiveness in the international market would be. That's all.
Thank you, sir. Thank you. So, Barun, I think so far in India, we are known as ferroalloy producers. I think if you had to add one more word before ferroalloys, refined ferroalloy producers. So if you have to look at overall refined alloys, I think it's growing almost 25-30%. It's growing big times, which is good news. And Joy Balaji has also grown significantly, not only in volume, I think you are also known for the quality. So obviously it is also in line with the quality of steel being produced across the globe, better quality steel, low carbon steel and everything. So what do you think that if India has to consistently grow in that space, because there is still a lot of space, how do you adopt, one part is the technology and second part is the cost competitiveness. So what do you think that India can still do better and to get some more market share in the refined alloys?
Thank you, Mr. Shishendu, for acknowledging our efforts towards the ferroalloy and the steel industry. I believe there is a growing demand in India as well as abroad, where the percentage of specialized steel is growing more than 20%. In India itself, there is a big growth for the aeronautic steel defense sector, whereas India is focusing more on Atmanirbhar, on the products. So to support this, we should have, apart from the economies of scale, which we have spoken upon the skilled labor, on the capex, on the big volumes, there should be a target also to produce niche ferroalloys, specialty ferroalloys. It's not only low carbon ferrochrome, but other low carbon ferromanganese specialized and refined processes of other ferroalloys, which is being imported into the country. We took as an initiative to stop the imports, and today we are, as a country, exporting the specialty ferroalloys to all the steel producers across the globe. But we would like to take this ahead in India, that all kinds of specialty or refined ferroalloys still being imported should be stopped and should be produced within India and have a from local to global market share. And we have the ability in terms of technology. In terms of cost, which was your second part, we have to be very cautious on when we choose our technology. As the gentleman has already spoken to me, made a point, and apart from the members of the dais over here, has spoken on the technology, on the skill of the manpower which we have currently. There has to be an ongoing process where the skill of the manpower has to be improved on every periodic basis. Apart from this, having a self-sustainable is very important. CBAM is just one of the issues. Apart from CBAM and sustainability, there has to be something called quality consciousness, which is very much important in our products, for which now India is being known globally that, okay, it's an Indian product, no need thinking twice on the quality. The quality is stable and standard. We have to make the country as a standard producer of specialized ferroalloys. For this, we should take a step forward, take our qualities seriously, supply to all the end steel plants with caution, and see that all the testing agencies support us and only good material is being produced and dispatched from all our units, supporting the industry in India as well as in the global market. Thank you.
Thanks for putting up your views. Now I put up a question to Mr. Sirsendu because he is very, very deep into steel industry, ferroalloys industry, and is a widely read person, very knowledgeable. Now I am putting a very contrarian view of the steel industry because steel and ferroalloys both are connected. We are seeing all the rosy pictures about steel, that 400 million ton by this year, 300 million ton by this year. Now, with the concept of green steel coming in picture, will it put a spoke in the wheel in our imagination that we will be really be able to produce 300 million tons? Second is, with so much of production, we will produce lot of wastes, which we never discuss. In all the industries, for 1 ton of steel produced, there is a lot of waste produced, which is much more than the steel produced. Now we do not have any thought about that. Once that is taken into green steel balancing, then are we in a comfortable situation? The third question. Whatever we are talking today, 168 million ton, 160 million ton, these figures include the secondary steel produced by the induction furnaces. Are we good enough to meet the quality standards there? Because today, the acceptable BI standards and the standard which are being produced and being marketed and sold in the market are almost about 20% of this or more than that. Because induction furnaces produce with phosphorus content of, I have seen, up to 0.18. Sulfur, both combined required is about 0.10, but then it is much, much above that, 80% above that. In this situation, how do you see the future of the steel industry?
I still start with the point number 1. I think if you look at India and I would say the India's national steel policy and the PM statement. See, I think 2065 is something that India is still looking at, carbon neutral. It's a long way to go. As a developing country, I think we are not looking at green steel, to be very, very honest. Even if we are going for the green steel, you have to look at the primary steel producers, which is Tata Steel, JSW, MNS, JSPL. If I look at these 4, that's about adding up to more than 100 million tons, close to 100 million tons. You might get some 3 to 4 million tons of green steel, which is hardly less than 5%. Not very significant, to be very honest. Neither government is proposing that India should adapt very fast. Because as a developing economy, and as I said, if your per capita income is $3,000, you don't buy steel at $800. So it's very simple. So while the thought is there, and I would also imagine that different companies will adapt it differently. The other challenge, apart from the technological challenges, is the scrap. See, the normal cycle of scrap coming back to the system is about 30 years. So China will adapt it fast because they have grown very fast, and the scraps will come back to the system. So that's about 1 billion ton of steel. It moved up from 400 to 1 billion ton in almost 10 years. Very, very fast. So those scraps will come back to the system. But for India, it's a long way to go. I think, I don't know. But my own sense is that 2060, 65. So therefore, even India today is still looking at BA route. India is not looking at EAF route. And all the primary steel producers, it's not like one company. So thought is there, but if Indian per capita income becomes $7,000, then suddenly everybody will think about it. So that's the point number 1. Point number 2, I think in terms of waste, I would say, whether if you look at BF slag, LD slag, I think now everything is utilized. I don't think that nothing is thrown back or nothing is dumped anywhere. We have slag, you know what is the usage? The cement industry is taking almost everything. Even in the sinter plant and other aspects, I think LD slag, all waste are being utilized. I can, in my earlier role, I can say that we are really ramping up utilization of those faster because we need to have space even inside the steel plant. So I would not say that India is not looking at it. We are looking at it very, very seriously. How do you really utilize whatever you are producing even as waste? How can you get value from waste? I forgot the third point. So it has to be, you know, we have to continue together. I don't think that India primary steel production capacity is not good enough to meet the demand of the country. Even though I would think that secondary steel producers are thinking about it to contain it, but as a process they cannot contain it unless there is some technological advancement will happen. But it will go, I would not say in a lot of even secondary producers are actually thinking to move into a primary domain. May not be the full volume, but part of their volume might come into primary steel, and then those BIS problems and other problems will get resolved. I hope I was able to respond to your queries. So I think thank you for all the panelists. I think it was a great discussing with all of you. And, oh, sorry.
One is about the, 2 minutes, Mr. Very recently, there is a study by Ernst Young on green steel requirement in India. And they have said that about 5 million ton of green steel will be required in 2027-28. And this will go up to about 65 million ton by 2030. And then it will go up exponentially. Their main focus is on infrastructure sector, infrastructure asset funded by public investment, number one. Number two, green building. If you ask any of the new residents who are purchasing, first thing they are asking the builder whether it is a green building. So green building concept is now caught on. So for that, whatever steel will be required, they will be asking the green steel. Your next question is of, secondary sector, which Shishendu has answered. They are a part and parcel of the total steel, fraternity. But many of them are now setting up ladle furnace as well as reheating furnace, so that the steel, whatever they are producing, is clean steel, much less of phosphorus, which is a major danger. About the wastage part, he has very aptly answered. All our slags are now going in for the building purposes, road building, etc. No steel plant is now, sort of complaining, but there is a huge emphasis on solid waste management inside the plant. And every large players, they are concentrating on that. And I am sure particularly the water conservation has gone to the extreme. There is no water discharge by many of the large steel plants. So that is a cause of, thank you.
Thank you.
A big round of applause, such a lovely panel, and each one of you. And I especially also thank the chairman for conducting it so well and finishing right on time. So before we go for a photograph, if you please, all of us, if you can stand here in the front. Come. Thank you very much, panelists. Now I'll request to go for our technical session 1, and I request to make the table that Professor Siddhartha Das, IIT Kharagpur, he'll be chairing the session, and Dr. Ravi Chaudhary, and I'll also request Professor and Dr. Siddhartha Das of IIT Kharagpur, please come on the dais. এটা দুটো ওইদিকে দাও আর একটা এইদিকে দাও।